example 5. And then I'm going to go ahead and drag that in if I can. I'm going to hit run, although I don't really need to. All right, so this one's also going to use example 5, k-fold cross-validation. Stochastic gradient descent. This one's also going to use the MINS data set. I'm going to load my data. I'm going to get rid of this description key just because I don't need it anymore. X and Y are still good. And then I still want to, I'll keep all of this. I want to split my X and Y, split X and Y. That looks pretty good. Now, I'm going to, let's extract a subset for our 5 decoder. I like that. And then I'm going to build a stochastic gradient descent underscore classifier is equal to sklearn.linear.model, STG linear model.
Which example did you copy?
Oh, example 4. And the last one you're working on, just so I can still bring in data, if that makes sense. I'm just kind of reusing all of it. And so this is where I get to, but for k-learns, I need to train my data on different subsets of my data. So I'm going to break that up into a for loop. And from here on out, I think I'm just going to delete it. And we'll just retype it all up. So build a 5 detector. Several times, so to see the variation in the metrics returned. So all right, so let's do that. Let's say for I in range 5. Train the model. We're going to go stochastic gradient descent class of stochastic gradient descent CLF.fit x underscore train y underscore train underscore 5 y underscore train underscore predict equals stochastic gradient descent underscore CLF dot predict x underscore train. And that will train it in my loop, and then use SK model to return my metrics. So, or use sklearn. So let's go metrics. Accuracy equals sk dot metrics dot accuracy underscore score. Train y underscore train underscore 5, comma y underscore train underscore predict. Precision is equal to sk.metrics dot precision underscore score, and then it's just going to be the exact same thing. I don't really know why I typed that out. I'm going to get rid of precision. Sorry, the capital P on precision. I'm going to copy this down again. We're going to change it all to recall. That's all we care about, right? And that should work. So now let's go ahead. I want to just print these. So, I mean, I can go through and find all these individually. Well, so let's go accuracy is plus str. I can definitely just put accuracy, but it gives me a ton of precision points, which I don't really care. Let's go np.round accuracy, comma 4. You know, for right now, I'm just going to hit F5 and see if that runs. Okay, good. It's running. So while it's running, I'll add to that. Plus, open up a new string, colon, space, precision is space plus str. np.round. Oh, accuracy was spelled wrong. Yeah. np.round precision com 4. Come out of round, come out of string, plus add another string, semicolon, space. Recall is plus str and p.round recall, comma 4. All right, let's see if that will return. So what I'm looking for are 5 different values right on top of each other, each trained with just retrain the stochastic gradient descent 5 different times. And what I hope I get are semi-decent spread in terms of accuracy, precision, and recall. Survey says okay, so I didn't have a space. Recall is space, but that's okay. The first one is 91% accuracy, not 52% precision, and 93% recall. So let's just see what the next ones are. 96% accuracy, that's pretty good. 92% precision, that's very good. But now a 71% recall, right? So just because we train a model once doesn't mean that we're really going to get the same things out. Now I'm up to 97%. That's my best so far. Precision is 93. That's great. Recall is 93. That one's all around better, right? Not actually, I mean, like if you don't care about recall, that one's pretty good. Here we go, 95. Precision dropped way down to 70%, 69%, and recall is 87%. So not so great. And then we'll wait for our last one. All right, and so we have 97%, that's pretty good. Precision's 94, recall 73. So that's kind of the variations that we get on our classifier. So let's do it again. How about we retrain our model now? So rerun with K full cross validation. I'm just going to copy it down. Now what's going to change here is how I train my model. So Y train predict. So I don't actually need this anymore. We're going to use a different Python call. Is equal to, we're going to push this all into one command. So ytrain predict is equal to sk.model underscore selection dot cross underscore val underscore predict. And I'm going to have stochastic gradient descent underscore CLF. So I'm going to have the same classifier I used before, x underscore train, that's some of my data, y underscore train underscore 5, because that's my data for my y detector. And let's go cross validation is equal to 3. So I'm going to split this up into 3 different bits. So the more I split it up, the smaller my data sets are. In theory, the tighter my, to a point, right? The tighter my, oh wait, I did not want to do that. I did definitely not want to do that. I want to highlight all of this and hit F9. And that's going to load my data in. And then I want to highlight this and hit F9. Just because I don't want to run my first 5. Okay, now I'll hit F9. And now it's training in a loop with cross validation. Should be giving me 5 different outputs. Let's see what they look like. And hopefully they have a tighter precision and recall. All right, so accuracy is 95%, precision is 77%, and recall is 76%. All right. We actually hadn't seen one where precision and recall were close to each other before. So that's a little interesting. Let's see what the next one looks like. Okay. Accuracy is 95%, precision is 74%, recall is 75%. That's pretty good, right? And the next one is 96%, 79%, and 80%. That one's actually better all the way around, but much tighter, right? So we no longer have high precision and low recall, or high recall and low precision, right? It's kind of converging on a much more stable data set. And again, this is for a classification on our digits, right? And so we think of a digit as something we can see, but the computer's just trying to build a linear classifier through those 748 different pixels that make up our image. Yeah.
I'm getting the syntax error with like just like printing the accuracy, precision, and recall, and I can't figure out what this is.
It's in this string somewhere. Accuracy is string round string. That one. Oh, you have string dot. That might not be your only one. That's one of them. All right, and there's the last one. So accuracy is 95%, precision is 78%, recall is 76%. So overall, these are a much tighter bunching than the last group.